Hello everyone. So last class you were absent. Till today how many are absent? Rohan Jaiswal. Why is not coming? You're Rohan Jaiswal. Okay. Then we have वो एक और है ना वो नहीं है क्या हुआ उसका एग्जाम है Okay, where did we stop last class? Page number. Force, right? We're doing force or gravitation? Page number 39, question number. Okay, so 15. Page 39, question number 15. So what is given in this question? You have a ball which is dropped from a height of 20 meters. The ball is dropped from a height of 20 meters. At the same time, another ball is thrown vertically upward. So there is another ball which is thrown upward. Okay. From the ground with a speed of 20 meters per second. So this is U2 is equal to 20 meters per second. And U1 is equal to 0. Correct? This ball is dropped, just dropped, and this is thrown up. And what about acceleration due to gravity? It is always downward. Then you have to take G as 10. Okay, that is given in the question. Now you have to find when and where will the two balls meet. So let us say the balls meet here at this point. At this point, let us say it has traveled distance x. Okay. So if this has traveled distance x and this ball reaches what height then? H minus x. So if this is h. So this distance will be how much? H minus x. And h is equal to 20 meters.
सर एक्सक्यूज मी
Yeah.
सभी नए बच्चों के लिए मैंने पॉलिनोमियल्स और नंबर सिस्टम एक्स्ट्रा लेक्चर रखा है सैटरडे 2 to 4. हाँ टाइम टेबल चेक करा अगर किसी को भी ज्वाइन करने का है प्लीज आ जाओ 2 to 4 एक्स्ट्रा लेक्चर.
You had attended last class or this is your first lecture? Okay. What's your name? Huh? Saransh. Okay, welcome Saransh. Which school you are from? Okay, fair enough. All right. So now, have you understood what we are doing here? The height from which the first ball was dropped is 20 meters. The moment this ball was dropped, simultaneously another ball was projected upward. With what speed? 20 meters per second. So then what is the question? Question is, at what time and where these two balls will meet? Okay, this is the question. So you have to find basically time of meeting and x. ये निकालो. Either x or h minus x. ये दो चीज निकालते हैं. This is the question. Right? So when you say h minus x, that means this much distance above the ground or this much distance below the roof. Okay. So solution. So just write the equations for upward and downward motion. For upward motion. For downward motion. What can you write? We have u, we have displacement, so that is x is equal to ut. So t is common. At time t, this ball reaches here, and at time t, this ball comes here. So t is common. So at ut plus half gt square. Okay. That is x is equal to, this becomes 0. Now this is equation 1. So we get this equation for downward motion. For upward motion, what will be the equation for upward motion? What is the vertical displacement? H minus x. Okay, h minus x as it is equal to UT. So in this case, G will be negative because for upward motion, it is acting as retardation. Yes, G will be negative. Okay, sign of G will be negative for upward motion. Okay, so therefore, h minus x is equal to U2 is how much? 20 T minus half dt. So now we'll substitute value of x from 1 over here. So therefore h minus half dt square. So by 1 into, what are we doing? We are substituting 1 in 2. So we get h minus half dt square equal to 20t minus half dt. So half dt and half dt will get cancelled. What is h? So 20. This gives us t is equal to 20 divided by 20, that is 1 second. So when will they meet? They will meet after 1 second. Okay, therefore, and if t is 1, so what do we get? X. So 5. Therefore, x is equal to 5 meter. Or h minus x is equal to 20 minus 5 is equal to 5. So what is the answer? Therefore, balls will meet after 1 second. At 15 meter above the ground. Or 5 meter below the. So how we have done this question is, here the time is same. That's how we have done. So just make two equations for downward and upward motion. Apply proper sign convention for G and then substitute the given data. Okay. So if anybody has any doubt can ask. You know the answer. Next question. So question 16. Shall we discuss? Everybody write today's date also. Can we discuss question 16? So this is a theory question. So who would like to answer? Define pressure.
Pressure is the force applied per unit area.
Yeah. Force, or more precisely, thrust per unit area. A normal force. When you say force, you say normal force or thrust applied per unit area. Then what is thrust then? Perpendicular force acting on any given crystal. What is the density of a substance? Yes. What's density of the substance? कैसे पूछ रहा हूँ? क्या नाम है? Danish. Danish, बताओ. The name is more similar to density. You should know what is the meaning of density. So that density is amount of mass contained in per unit volume. Density is mass per unit volume. So that's density. Relative density is not in the syllabus, but it is asked. So basically, relative density is basically comparison of density of substance with density of water. It is the ratio of density of substance to the density of water. For your information, density of water is 1000 kg per meter cube. 10 to the power 3 kilogram per meter cube. That is standard. And in CGS unit, it is 1 gram per centimeter cube. So density of water, you should know like the value of G. Okay, ये पता होना चाहिए. So any substance whose density is greater than density of water will sink in water, will not float. Okay, anything whose density is less than water will float in water. The law of flotation. So for that you have to know the density of water to be able to compare. So all the substances whose relative density is greater than 1 will sink in water. Okay. So what is the relative density of mercury? It's 13.6.
Yes.
So it will sink in water. Like that.
That Peter, what is the ratio?
Relative density. Relative density. So relative density is given as density of substance divided by density of water. Okay, that is RD is equal to 1 density of water. Symbol for density is rho, RHO, rho. Okay. So now suppose I give density of water. This is 1000 kg per meter cube. Or 1 gram per centimeter. So it is easy to remember. ठीक है? So कोई भी substance जिसका density ज़्यादा है, so जैसे density of mercury is 13.6 into 10 raised to 3 kg per meter cube. ठीक है? This is also very common, density of mercury. So if it is density of iron, obviously has to be more than even this, but this is still liquid, right? So iron's density is going to be even more than that. So it's going to sink. Now why relative density is important is because it is very easy to calculate relative density of any substance experimentally. Once we know relative density of any substance, then density of the substance can easily be calculated. It is equal to relative density into density of water, and this is known to us. We need to know the relative density to be able to calculate the density of the substance. Okay. What is buoyancy? हमने अटेंड किया था buoyancy. Last class अटेंड किया था तुमने? तो buoyancy बनाया था. Flotation अटेंड किया था? तो फिर तुमने नहीं. You had attended last class? नहीं, last class में there were many people absent, right? So who had attended? You had attended. Danish was also there. Okay. So then everybody was there. So what is buoyancy?
The property of fluid to exert force.
Force or upthrust? So upthrust, मतलब if you try to submerge any object in liquid, liquid tries to exert upthrust on it. So what due to that? What because of upthrust? Let's say you enter into a water body. What do you feel? Huh? Light. So you feel light because there is a gravity pulling you down, and liquid is applying upthrust on you. So you feel that your weight is reduced. Okay, you feel like floating a little bit. Okay, so this is what happens. So upthrust is that property of liquid to apply upthrust on any body being submerged is called buoyancy. That property is called buoyancy. Okay. Then Pascal. What is a Pascal? Not Pascal. Pascal is unit of pressure, which is thrust per unit area, which is Newton per meter square. Okay, that's Pascal. Okay. Question number 17. A piece of iron sinks in water, but a ship made of iron floats. Explain.
First, force is equals to pressure.
Right. Okay. You don't be afraid of making mistake. My class, you are allowed to make mistake, but also correctly. What is the principle of flotation? What objects will float whose density is less than the density of water? Yes. Only the outer part has metal. Okay. But what about the full volume? Density के लिए you have to take into account ship's volume also. So mass per unit volume of the ship, that is zero. Okay. Now this ship is, let us say, this much inside. So ये part जो ship का है, उसका वॉल्यूम, उसका जो वॉल्यूम है उसमें जो मेटल का पार्ट है वो तो खाली आउटर पार्ट में ही है ना, लेकिन वाटर तो इसने पूरा रिप्लेस कर दिया. तो full volume of water, it's like when you fill this much portion of the ship with water and weigh it, the mass of that water will be more than the mass of the only metal sheet of which the ship is made, because वो part में ship के अंदर air है. So density of air is less than density of water. Understand? So that's why the average density of the submerged portion of the ship inside water is much less than the water displaced. मतलब the weight of water, Archimedes principle, the weight of water displaced by the submerged portion of ship is much more than the weight of the entire ship. It's clear for all. So those who have missed the Archimedes principle will not understand. When did I tell Archimedes principle? The last class, or did you attend Archimedes? So then you should understand this.
Class.
So what answer you will write? The piece of iron sinks in water, but a ship made of iron floats because the average density, write down. The average density of the submerged, the average density of the ship, उसमें submerged नहीं लिखना है, average density पूरा full ship लेना होगा. The average density of the ship is less than the density of water. Okay? The average density of the ship is less than the density of water. That's why it floats. Okay, next. A body of why the average density of the ship is less? Because the hollow portion has air. It's not solid metal. So air density is much less. And air is occupying the larger volume. Metal is only in the outer surface of the ship. Okay. So you want to write it mathematically. Average density. This is the average density of the metal part of the ship, metal sheet, plus density of air content inside the ship divided by volume of the ship. And this calculation will be less than density of water. ये average है. Mass होना चाहिए density. क्या होगा? Mass. So mass of the metal part of the ship, mass of the air in the ship. ये total mass हो गया divided by total volume of ship. So this is the average. Yes. ठीक है. चलो next question. Question 18. Everybody read question 18. You got the volume? No? ये मिला क्या तुमको? So question 18 is a body of weight W. A body of weight W units floats in water. What will be the weight of the water displaced by it? Yes, at least.
should be equal or more than,
Huh?
should be equal or more.
Weight displaced by it should be, if it is less, then it will be half inside and half outside. If it is equal, then it will float with submerged fully inside, but it will remain on the surface. So you assume it is equal. Less than or equal. So more, weight greater than or equal. Okay, it will only float in two situations. If the weight of the water displaced is greater or equal. If it is greater, then it will be half outside, half inside. If it is equal, then it will be fully submerged but float like that. What mesmerized you? Float हो रहा है क्या? समझ में आया आंसर? नहीं आया, नहीं आया, इसीलिए आंसर आर्किमिडीज प्रिंसिपल क्या है? पढ़ो प्रिंसिपल, आर्किमिडीज प्रिंसिपल नोट्स में लिखा है, नोट्स में लिखो आंसर. You cannot answer this question unless you know what is Archimedes principle. मतलब check करो Archimedes principle लिखा है. What is written? Read it loud.
The point force acting on the object is given by the Archimedes principle by the Archimedes principle. What is the force equals to weight of the case liquid by the submerged portion of the body plus.
क्या बोलता है Archimedes principle? The weight displaced by the submerged part of the body is equal to the upthrust acting on the body. Archimedes principle gives you how much upthrust the liquid is applying. So upthrust is equal to the weight of liquid displaced by the body. तो इस केस में अगर इस पे जो अपथ्रस्ट लग रहा है वो इसके वेट से ज्यादा है तभी तो फ्लोट होगा. When will I able to hold any substance? When the force applied by me is greater than its weight or at least equal to its weight. है ना? If it is greater than वो ऊपर धकेल देगा because net force in upward direction will be more. ठीक है? If it is equal, then it will be stationary. If this weight is more, then it will keep on going down. ठीक है? इस केस में क्या होगा? At equilibrium, मतलब whenever the body is floating, then it has to be equal only because it is stationary now, not greater. It will be equal. It has to be equal. Whenever the body is floating, at that time, whatever water is displaced is equal to the weight. Look, it is stationary. So it is equal to W, not greater. Greater कब होगा? Suppose मैंने ship को ऐसे दबाया, still it is not sunk. So this extra force which I am doing is displacing more water. That time the displaced water weight is more than the weight of the ship because now ship is also experiencing some external force. But for a floating body, the upthrust is always equal to the weight of the floating body. Is that clear?
That the weight of the body and the water displays
Is equal, both same. W only. In case of floating body, weight is same. Okay. Question 19. Who would like to answer? Why is it difficult to hold a school bag with a thin strap? Look at the straps of your bags. Is it thin or wide? What if it was thin, just a rope? What will you feel when the bag is fully loaded? It will start hurting, right? More pressure, because pressure is more pressure. So it will begin to hurt. है? Why more pressure? Because the surface area is less. Pressure is F by A. When the strap is thin, area will be less. and this will cause high pressure. तो high pressure से क्या होगा? वहां पे ज्यादा पेन होगा. It's like somebody, you know, is putting a knife on your shoulder, right? Instead of sharp knife, if it is blunt, it won't hurt you that much. But if it is sharp, you lose one shoulder. Like a sword. Sword blunt होता है. If it is a rod, it will hit you, but it will not cut. But if it is a sword, it will cut it. Because it will generate a lot of pressure. Rod will not be able to generate pressure to detach the arm. Again, it depends how hard somebody will hit. Okay. Next. Why does an object float or sink when placed on a surface of water? It floats when its density is less than the density of water. It sinks when its density is more than the density of water. Question number 21. You find your mass to be 42 kg on a weighing machine. Is your mass more or less than 42 kg? That is a tricky question. What it should be? So when you are standing on the weighing balance, what is happening? Is there any upthrust acting on you? So gravity है तो क्या होगा? Mass basically remains same anywhere, right? Mass will not change. So let us say like the weighing machine is kept at pole, right? Then the weight might be different, but mass remains same only. So mass of the body will remain same. Weight may change. Okay? So it remains 42 kg. Mass is a constant quantity for any given body. But the weighing machine is calibrated to show mass only because G is divided.
But mass is given, so 42 kg is the mass.
The interpretation of the question, it will depend on how you interpret the question. Mass as a quantity remains constant, but when somebody is weighing, like let's say I'm holding a weight, okay? Now I'm keeping it on a weighing balance, but I'm not fully left it. I am slightly trying to hold it upward. So will it show the full weight or less weight? Full mass or less mass? Less mass. So if somebody like if some upthrust is acting on you, in that case the mass shown will be less. So the answer could be less in the scenario I just explained, or it will be same. If the weighing balance is kept from place to place.
It is same. And it is same.
I said that there could be different answers depending upon how you interpret. Okay? So it could be less because there could be some upthrust due to air. Like if it is a cotton, right? A cotton bundle, right? And if you take a block of metal block, let's say they have same mass, but still they might show different weight. Because the upthrust is on a larger surface area of a cotton bundle. So it may be, you may feel lighter while you're weighing the cotton. But when you're weighing the metal block, you may feel heavier. So such kind of interpretation-based questions might be there. You know, so both answers are correct depending upon how you're assuming the situation or reading the situation. Okay, okay, let's do the classwork numerical. This chapter is completed in your schools? Started? What is going on?
Second chapter. It's finished with.
Also, okay, let's do the first numerical, which is cuboid of sides 40 centimeter, 20 centimeter, 10 centimeter has a mass of 10 kg. Find the pressure exerted. So given mass, question. This is question number 1 on page 39. So, 40, 20, and 10. So this is a cuboid. The cuboid length given is 40 centimeter. 10 centimeter is its breadth and height is 10 centimeter. Okay. This is the breadth and this is the height. Find the pressure exerted by the wooden block on the surface when placed on its base. So you can keep the cube like this. You know, how can you keep like this? Or you can keep it like this, or you can keep it like this. Okay, you can keep it on different bases. Okay, so that's how the question is given. You have to find out the pressure in different situations. So case 1. So what is the area? The area is 20 into 10. And mass of this is given as 10 kg. So it is 0.2 meter into 0.1 meter. So this is 0.2 meter square. Right? So what is pressure then? Therefore P1 is equal to force per A1. What is force? Gravitational force. This is how it will be. Force will be its weight. Right? How much G you have to take? G given in the question is 9.8. So 10 into 9.8. Right? So this is Newton or kg meter per second. So that's the force. 10 kg and 9.8 meter per second square divided by area is this person. इसको तुम न्यूटन ले लो ना न्यूटन फोर्स तो न्यूटन में है न्यूटन पर कितना हो गया ये 4.9 to 10 raised to 3 awesome. ठीक है so this is nothing but 4900 cost. In the first case we got pressure as this much 4900 cost. So likewise you can calculate for the other two. What is the area in the second case? 0.1 into 0.4. So therefore P2 will be equal to what? It will be, this is 98, right? So now you will see that this is 98 by 0.04. So it will be half of this. So what is half of this? So it will be 2850. Similarly, what is the third one? 20 by 40. So it will be 0.08, which is even half of this. Okay, so you can calculate that yourself. So for last, you'll get the answer as 1225. Pascal or Newton per meter square, anything you can. So here you have a question on relative density. So what is the formula for relative density? Hence, relative density is equal to density of substance upon density of water. Therefore, density of substance is equal to relative density into density of water. So relative density of gold is given to you as 19.3. Density of water given is 10⁸. Now relative density has no unit because it is ratio of similar physical quantities. So it will be just a pure number. Okay. So how much is this? That is it. This is the density of fluid. Okay. So generally when we express the answer, we put the decimal after first digit. So this becomes 10⁴. Just by shifting the decimal. So try question 3. You are provided with density of mercury as 13.6 in SI unit. Convert that into CGS unit. Done? Yes. What is the answer for the first part? So we have density of mercury nineteen 14.6 10 raised to 3 kg per meter cube. So how much is this? 13.6 into 10 raised to 3 kg is 1000 gram and meter is how many centimeter? 10 raised to 2 centimeter and minus 3 power will come. How much is a meter? 10 raised to 2. Now simplify. So this is 10 raised to 3 or to 10 raised to minus 6 gram per centimeter cube. Right? So this power will be multiplied. So this 2 into minus 3 minus 6 and centimeter per cube. How much is this? 13.6 10 raised to 6. So it is only 13.6. Okay. So it will be 10 raised to 6 minus 6. 10 raised to 0, which is 1. What is its relative density? So relative density is equal to density of mercury divided by density of water. Density of mercury is 13.6. Density of water is 10 raised to 3. So this will be just 14.6. Just the number. No units. Okay. So you have, so there are only how much? 10 minutes remaining, right? Little over 10 or 10 minutes. So what you do is you do the questions. I'll start the chapter in the next class. You don't have small, you can just go through it. So try to solve questions from worksheet and any other question you may want to. Or shall I discuss the worksheet questions with you? Who said no? Right. Relative density is not in the syllabus. I don't see it in the book, but it is there in the volume. One. Okay, let's take up some. Look at question 14 on page number 41. This question. Okay. So there are three different containers filled with three different liquid, means liquid of different densities. Then the liquids are filled in all the three containers at the same level. Okay. Now the shape of the container is same, but their width is different. The amount of liquid is different, but same height. And first container density of liquid is least, and this is maximum. Then what is asked is, if P1, P2, P3 are the pressure at the base of ABC, right? Then what is the relation? What is the relation between P1, P2, and P3? So how you have to mention the relation? Equal to, less than, or greater than, comparatively. Which pressure will be?
P1 will be the highest.
P1 will be highest or lowest? Which density is greatest?
Yes.
In case of solids, not in case of liquids. How is the pressure given for liquids? Does it depend on the shape? It only depends on height. Okay. So between these three containers, height is constant, density is different, G is also constant, therefore pressure will change with density now. Okay. So if the density is increasing from A to B, so density of one will be, pressure of one will be less than, directly proportional to density, right? Less than P. In case of liquid, the pressure is given by this formula, correct? The liquid pressure is slightly different. Okay. So region is given. Now, next. What is the answer in the first part? This and this are same in all cases. What is same?
Height.
Height and gravity. Okay, so first case में G are same. Second case. What is the greatest of liquid in A? What is greatest?
This will be.
Nothing is greatest.
So what should be the greatest?
I don't know. It doesn't make sense here. We have height, we have density, we have gravity. So, is it for the same liquid? There are different quantities. Height is same only. So this question doesn't make sense. तो lowest लिखना चाहिए. Lowest बोलता तो density is lowest हो सकता था. Greatest तो है नहीं. Okay. Third में क्या है? Of the container has no effect on the pressure at the base. What is the answer to the third part? Just mark second. Second को एक asterisk या arrow mark करके रखो. Area of the container or shape of the container? Shape से भी कुछ नहीं होगा. What matters is only the level, height. Okay, next. Can you do this question? Question 15. What is shown in the 15 is hydraulic lift. What is it? Hydraulic lift. Means if there are two cylinders here, one cylinder is thin, the other is thicker, wider. So when you press on one side, the other side will go up. So this is hydraulic lift. Like I said in car garage, the car is kept on the wider platform. When the force is applied on, pressure is applied on the smaller platform, okay, smaller piston, then the car will lift up. So now answer the question. Area of piston A is 1 centimeter square and B is 2 centimeters square. How much weight is required to balance the weight placed on A? What is weight? What is the weight placed on A? 1 kg. So, are you sure? Pressure is same on both sides. As per Pascal's law of transmission. What is Pascal's law? Pressure transmitted is same. It's not going to change. ज्यादा हो गया इसके लिए तुम लोग अलग अलग देखो बताओ तो सही ठीक है तो इसमें तुमको देखो ये लॉ है P on A will be equal to P on B. What is P on A? P on A will be pressure is force upon these are two cylinders, no? A and B. So by Pascal's law, PA will be equal to PB. Whatever pressure this force on A is applying, same pressure will be transmitted. So that's what. So FB will be equal to AB upon AA times F. ये आंसर होगा इसमें. So FA and FB are the weights. तो ये कैसे आएगा? 1 into G. Okay, that is how it is. Okay.
That